quadratic sequences. Now I've already shown you an example of a quadratic sequence, and in this particular case I'm going to touch more on that. And so let's look at that example of that quadratic sequence. 4, 7, 12, 18. 4, and let's get a thin pen going. 4, 7, 12, and 18. Right, and so what I'm interested in here is determining whether the sequence is quadratic, and the way I do that is by seeing if there's a constant second difference. So between 4 and 7 I'm adding 3, between 7 and 12 I'm adding 5, and between 12 and 18, well, let's make that 12 and 19, my apologies, otherwise it's not quadratic. 12 and 19, I'm going to be adding a total of 7. And so what happens between each of these first differences? This is a sequence of first differences. Okay? And so what happens over here is I'm going to say, well, you're adding plus 2 and plus 2. And so when I have a constant second difference, things qualify as a quadratic sequence, right? As a quadratic sequence. Okay, and so sometimes you're going to, one of the most common questions that we have to deal with in this section is, when we're talking about quadratic sequences, find a general formula for the sequence. A general formula for the sequence. Or it may ask you, okay, so you may be asked to find the general formula, or they may ask you to find Tn, or they may ask you to find the nth term. Right, so the nth term is just the general term. It means n could take the form of any position, and that's what we're really interested in. Okay, so let's look at this, and I'm going to bring this up 4, 7, 12, and 19 on the next page again. 4, 7, 12, and 19, and there's a quick process for how to do this. And then let's look at the differences there. That was plus 3, plus 5, and plus 7, and then the difference here is going to be plus 2, and so forth. Right. Okay, so quick questions. Very simple formula. The general formula for a quadratic sequence is actually Tn equals an squared plus bn plus c. Now I'm going to tell you that Tn is a function of n. And now because Tn is a function of n, I need to actually calculate and work out what is a, b, and c going to be. And then I need to determine, okay, if I throw in an n, what am I going to get out as a Tn? And there's a simple way to do this. So let's look at that. This here is your second difference, right? This here is your first difference, and this here is your first term. This over here we equate to 2a, right? This over here we equate to 3a plus b. And the final one above we equate to a plus b plus c. And now I'm going to show you in an alternative video how to manipulate this if you're not given the first term, but you need to look at the second or the third term. So a plus b plus c. And we're going to start from the bottom, right? And what we're doing up is we're building up this thing. So let's see, how do we do this? We're going to say, okay, 2a is equal to this term over here. So 2a equals 2. Therefore, when I solve this, I say a equals, divide both sides by 2, and I say a equals 1. Okay, 2 times what will give me 2, therefore that must be 1. Okay, so let's go to the next one, and I'm going to say I use this value and I'm going to plug it into 3a plus b. And 3a plus b I equate to 3. Okay. And when I substitute this in, I'm going to say 3. I'm going to take that blue one over there that's right next to it, and that's where my 1 is coming from. Okay. Is equal to 3. And so this tells me something. This tells me that b has a value of 0. Why? Because 3 times 1 is 3. 3 plus nothing still gives me 3. So b, when I solve that equation, I get b equals 0. Okay, and then finally, I take both values now and I plug it into a plus b plus c. And I say, that's going to equate to 4. So a I take from here, and I say a is 1, and I say b is equal to 0, and I say c is equal to 4. Right, a plus b plus c. Now, if I look at this, I need to say 1 plus 0 is 1, and I subtract 1 from both sides, 4 minus 1, and then I'm going to get c is equal to 3. And so now I've got all the coefficients for this formula over here, and I'm going to use that to solve the equation. Tn is equal to a, which is 1, 1n squared plus 0b, right, plus 3. And that simplifies to n squared plus 3. Okay. And now let's see what we get if we do this. N squared plus 3, and that's our Tn. Now remember, if I want the first term, I say T1 is going to equal to 1 squared plus 3. And that's going to give me 4. So there's my first term. What about T2? It's going to be 2 squared plus 3. And that's going to give me 7. And what about 3? It's going to be 3 squared plus 3, which is going to give me 12. So there's my sequence, 4, 7, 12. What about 4? T4, I put 4 in n, and I'm going to get 4 squared plus 3 is equal to 16 plus 3, and that's 19. And there you can see that that formula, the general formula for quadratic sequence, is Tn equals an squared plus bn plus c. And how we find this an squared plus bn plus c, we need to find the a, we need to find the b, and we need to find the c. And that comes from this: 2a equals 2, 3a plus b equals 3, and a plus b plus c equals 4. And that's the first example. In the next one, we're going to find the terms, or rather the formula for a quadratic sequence, again using 2a equals the second difference, 3a plus b equals the first difference, and a plus b plus c equals the second difference, and then we will test the sequence as well.